Okay, rotations, the most fun transformation of all. I think these are the trickiest, especially if you're a non-visual person. So I'm going to do this both with a visual dynamic and also like an algebraic rule. But I do want you to see both, guys, because if you see both, then if you get stuck and in trouble, hopefully you can reason your way out of it. When you rotate an object, the idea is that it's spinning. You know, like it could spin around the axis maybe this way, or it can move around the plane this way, and we call that clockwise or counterclockwise. So hopefully we know how to read a clock, because that's going to be your directions. And for our first example, I want to talk to you about taking an image and moving it, let's say 90 degrees counterclockwise. So counterclockwise if you want to write it out, but counterclockwise, if you think of a clock, it goes the opposite direction. So we're spinning our object this way and we're rotating it by 90 degrees. So the easiest way to, in my mind, the easiest way to visualize this is to go point by point or vertex by vertex and really look at how do I get to my axis, my origin rather. I always think about how do I get from here to my origin, and then I just do the opposite of that in order to make a 90-degree angle. So in other words, I'm going to draw a little vector, or whatever you want to call that. I'm going to draw a little line here from X to the origin, and I'm just going to think about how I got from X down here. Well, I went down 3 and I went over 2. I need to do that same idea over in this quadrant, but I want this to make a 90-degree angle, and I want it to look the same length as this. So this looks right, and I actually know that I did this exactly right because the slope is the negative reciprocal. In other words, we learned this on our last test, remember? We're trying to do 90 degrees, which is perpendicular, correct? Well, this slope is up 3 over 2. But when I look at this blue line, it is up 2 over 3. And it's in the opposite direction. So I have perpendicular slopes, which means that's for sure 90, which means that this point, this red point here, ends up moving right here. So if you want to do this with numbers, let's just take a look. The pre-image was at the point 2, 3. Okay, where did it move when I moved it over here? Well, when I rotated it 90 degrees, it moved to now the point -3, +2. So there are some people that like to just draw it and think about opposite slopes. So down 3 over 2, and then it's like, oh, up 2 over 3 the other way. So that makes sense to some people, or some people just want to look at this and go, okay, so what you really just did, Miss Mink, was you took the X and the Y and you flipped them, right? You put Y in front of X, but you also had to make that guy negative. So some people want a rule to memorize. There's your rule to memorize if that's you. Okay, if it's not you, then just draw it and move it to the correct spot. And we could do that with all of these points. So we could take Y, and I'm going to do it with slope, okay? It goes from here to here. I need to go down 5 over 3. That means now I need to go up 3 and over 5. So I know that Y is going to end up right there when it gets rotated. So there's X and Y, there's Y, there's X. Now let's take Z. Z is 5, let's do slope, up 3 over 5. So now I need to go up 3 over 5, up 5 over 3. So Z is going to end up here. So I just did the exact opposite slope in order to move it. And hopefully that'll work out with the points, right? So if I take the point 5, 3, and I do this rule, it should be -3, 5. 1, 2, 3, 1, 2, 3. Ooh, it worked. So as you can see, or hopefully you can see it, the base of this, I'm going to erase these fellas. The base of this ended up here. The XZ here ended up here. And then let me highlight this one. I just want you to see the rotation. So we're spinning this object, we're rotating it around. So as we're spinning it through the air and rotating it, this is where everybody goes and everybody lands, and this is where their points end up. That's how you do a rotation. So that's a 90 degrees rotation. We're going to go back and talk about 2 more, but we're going to do this with the notes guide that you have, okay? So if you go back to this sheet, we just talked about 90 degrees for counterclockwise, and when that happened, basically we're just writing that rule, folks. So the rule is what? The rule is that xy turns into negative yx. And when you do 180 degrees, this one I'm not going to demo because I actually think this is the easiest one of all. You're spinning an object completely around in the exact opposite direction. So if you do a complete 180, a saying in real life, right? Let's do a complete 180. If you do a complete 180, you negate it. You end up with exact opposites in terms of negative. We're not going to switch their places, but what'll happen is everybody's going to end up negative from where they were before. And so that's how that would work. 270 is a little harder for people to understand. Now with 270, I want to make a side note. Rotating 270 counterclockwise is the same as going clockwise 90 degrees. I hope that makes sense. For some people, it's like, oh my gosh, we're going to go counterclockwise 270. Like, that is way freaking far away. It's easier for them to instead visualize just going 90 degrees clockwise and putting their points in the correct position. And what happens when you do that is it's similar to the one up here, okay? But the x and the y are going to switch, but now since you're going sort of into another quadrant or you're going a little bit further, the x is what ends up getting negated. And you'll see it, guys, when you actually draw it down here. Feel free to use these rules first, okay? Use the rules first, plot those points, and then I want you to really look at your picture and see what in the heck just happened. So let's do something. All right, so let's start with not number 1 because I did that one on the example. Let's start with number 2. So I'm going to do square PQRS. So P is 2, 6. 1, 2, 3, 4, 5, 6. That's P. Q is 6, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 5, 1. 1, 2, 3, 4, 5. So this one is R. P, Q, R. Okay, S is 1, 2. Alright, that doesn't look very squarish, but that's probably my fault. Okay, so there we go. Oh yeah, I guess it's a square. Okay, so we have square PQRS, and we're supposed to rotate this 180 degrees. So if you want to do it visually, the idea is that this point S needs to move 180. So if you connect it to the origin, gosh, I hate this fat highlighter, y'all. It makes life so difficult. Let's do this. If we connect this point to the origin, we have to go the same exact amount in the opposite direction. So if this is like up 2 over 1, it's now down 2 over 1 because that's what's going to create a straight line. There's my 180 degrees, guys. Remember, 180 degrees is a straight line. So S is going to shoot right here. Now, algebraically, where did that S end up? Well, it ended up at -1, -2. Does that follow the rule from above? Did xy turn into -x, -y? Well, S was this, and now it is this. So did it work? Yes, it worked. So now we could draw every single one of these with a straight line to the origin if you want, or we could just use our rule. So R should be -5, -1. Q should be -6, -5, and P should be -2, -6. So notice I'm just doing this, like I'm just using the rule from above. And I'm going to draw them and see if it looks right. -2, 1, 2, 3, 4, 5, 6, good. -6, -5, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5. The hardest part here is just counting for me. I don't know, y'all may be better at that. but I can't see these. Okay, and then what's left? -5, -1, 1, 2, 3, 4, 5. Okay, great. And there is our square. So you can tell that, you know, if you were to look at this, and if the easiest way for me to see that I've done it right is I usually like to go like corner to corner, like the furthest one away to the furthest one away. And if I see that straight line happening through the middle of my paper, I usually feel pretty confident that I know what's up. I'm like, oh yeah, that's 180 degrees. It's a straight line from corner to corner. I must have done something right. So that's how that works. And these are tricky. So if you, like I said, if you come across some that say clockwise, just know that it converts back to these. There's another one I should have written on here. I guess 90 degrees counterclockwise is the same thing as if they said same as 270 counter. No. Clockwise, 270 clockwise. So if they say 90 degrees counterclockwise, that's also the same as 270 clockwise. So you just might want to add those to your notes so that you have a little something to look at. But good luck with rotations. Like I said, these are the hardest. They take the most brain power. Either understand the drawing it out or memorize these dang rules and have fun.